My name is Taylor. I'm the marketing manager here at Grid.ai and PyTorch Lightning. And we're very excited to have everybody here and joining for our first Lightning contributor meetup. And Aniket Maurya is actually one of our contributors and Lightning members, as well as Flash maintainers. And this meetup is going to be on Lightning Flash. So in just a minute here, we'll have Aniket take it off, but just a few logistics before we get started. So right now this meeting is being recorded. It will be sent to you in the next day or two if you need it. And if you have any questions, please ask them in the Q&A tab, which is down below, and we will answer them at the end of the meetup as well. Okay, it looks like we have a fair amount of people joining. So what I'm going to do is I'll go ahead and pass it over to you, Aniket, and you can take it away. Let me know if you...
Yeah, okay. Thank you, Taylor.
Yeah, you're welcome.
Thank you for the introduction. Hi, everyone. I am sharing my screen. Okay, let me know if it is visible. So, hi, everyone. Thanks a lot, Taylor, for inviting me to this meetup. And my name is Aniket Maurya, and I am a machine learning engineer at Conway Technology in Bangalore, India. And I am a contributor of Lightning Flash. So before starting, let me tell you how I started PyTorch Lightning Flash and how I became the contributor of this amazing library. So I started learning PyTorch this year around January or February. And I got to know about this cool library, PyTorch Lightning. I was previously using TensorFlow and Keras, so I really didn't like writing training loops in PyTorch. So when I started using PyTorch Lightning, it was really cool. It provided a lot of cool loggers and callback systems. It was really good. It removes all the boilerplate in my code. Then I got to know about Lightning Flash. I started using it, and it basically removes everything that is not required when I am training a model and I am focusing on building a product. So that's how I started using Lightning Flash. And for contributing, my first contribution was a documentation fix in PyTorch Lightning. And by that fix, I got to know about basic Git commands and all those things. I really didn't know anything about Git, how to use it. But after that, contributing to the documentation fix, I started to contributing few of the code fixes, and then I began to explore code base of Lightning Flash and started contributing to Lightning Flash. And my first contribution was integrating TIM library, which is PyTorch image models, which now provides more than hundreds of image models to Flash. Then in the taskathon organized by PyTorch Lightning, I contributed to integration of semantic segmentation models, which now has a lot of semantic segmentation models that you can use to build your image segmentation model and train and fine tune it. So let's start the today's agenda. What is Flash and why should I use it? Then I will talk about the task-based APIs offered by PyTorch Lightning Flash. And then I will talk about my contribution to Flash and integrations available in Flash. So first of all, model training overview. How you train a regular model in PyTorch, then you shift to PyTorch Lightning and how it converts to Lightning Flash. So first of all, you load a model, then you prepare data set, and you define your loss function, cross entropy or binary cross entropy. Then you create an optimizer. It can be Adams, SGD, or anything of your choice. And then you define a training step, which basically takes your model and your data, predicts the data, and gets a loss from your predicted value and the ground truth value. Then you basically combine all these steps to train your model with backpropagation loss. After this, you can, with PyTorch Lightning, it can encapsulate all these steps into a single module called PyTorch PL.Lightning module. And the forward function in the PL module defines the model forward function. Basically, it will take your data and run it through the model and return the logics. Configure optimizer method defines your optimizer, and training step will define the training step for your model. You can also put validation step. Then you have PL.data module, which you can use to build the data set. So basic components of Lightning, you create a class and inherits Lightning module. Then you define an init method, which will load your model, load a loss function, and anything that you need. Then you define forward function, and after that you define a configure optimizer, then training step. After you build this Lightning class, you create a pl.trainer. You provide all the configurations like number of epochs and callbacks and all. And after you have instantiated a model from this lit model class, you can use your data module to train your model. So Lightning makes it really easy. You didn't have to write your own training loop here. Now, where does Flash fits into all of this? So you have a pure PyTorch code, which you can scale and reduce all the boilerplate with Lightning. Then Flash provides a lot of task-based APIs for which you don't even have to write any Lightning module code as well. So what do I mean when I say task-based API? Suppose I have a task called text classification. Now in text classification, I have a given text. I want to know what is the sentiment of this text. Suppose a text can be positive, or a sentence can also be a negative sentence. So for sentiment analysis model, what I can do is from flash.text, import text classification and text classifier. My text classification is my task here. So I imported text classifier and text classification data, which provides in pre-built methods for loading data from CSV. So here I have specified the dataset path train.csv and valid.csv. I have also specified the backbone which I want to use for building this model. After this, I instantiate a text classifier model, and then I create a trainer. I specified maximum epochs, number of GPUs. I then fine-tune my model with strategy freeze, which basically frees my backbone. After fine-tuning, I can predict on the text that I have. So Flash really makes all these things encapsulated and abstracted, and I can just focus on what I want to do. With Flash, you do not have any boilerplate. You get all the features of PyTorch Lightning. You have a faster prototype and multiple training recipes available to you. Flash also provides Flash 0, which has low code. If you do not have any experience in machine learning or even in Python, you can use CLI to build and train your model. It has amazing integration with a lot of PyTorch ecosystem libraries like TIM, PyTorch semantic segmentation models, and Whistle and all. So now I will start with my notebook here. Like I said, Flash is a framework of tasks for fast prototyping, baselining, fine-tuning, solving business and scientific problems with deep learning. It focuses on prediction, fine-tuning, and task-based training. Currently, it has image, text, audio, tabular, and video tasks. So image contains classification, image segmentation, object detection, style transfer. And in text module, we have text classification, question answering. In audio, we have audio classification, speech recognition. And it doesn't only contains computer vision and NLP, it also contains training module for tabular datasets as well. You can do tabular classification as well as tabular regression. It also has video classification APIs. So how can you install Flash? You can do pip install Lightning Flash, but I have here used the latest version, which is not required in all the cases, but I wanted to use the latest code from Lightning. So after installing Lightning Flash, here I will show you an image classification training with pure PyTorch. And then I will show you how all this code can be reduced and all the boilerplates can be removed with PyTorch Lightning Flash. So like I showed initially, while training an image classification or any deep learning model, you load a data set, build the model, create a loss function and an optimizer, and then train the model. Here you can see I have imported torch vision and then created a transforms. Then I have loaded my CFA10 dataset. After loading the CFA10 dataset, I have done some visualizations. Let me show you. Okay, it is download. So it is available in my Git as well. But this code will basically show all the images in my, show some of the images available in my data set. And after that, I have defined my neural network model, which is a convolution network. And in PyTorch, for building an image classification model, we use convolution block. So from torch.nn, I have imported the nn module, which this class net is being inherited from. Then I have initialized con block, then fully connected block, max pooling block. And in the forward function, this X is my image, batched image, and I run through all the layers of my neural network, convolutional neural network, and I get the logits. Then I have initialized my optimizer and loss function, which are optimizer and criterion. Then I write a training loop. I iterate through my train loader, data loader. I get the inputs and labels. Then I set my gradients, gradients to 0 with optimizer.0 grad. I run my inputs through the model. Then I use the output and my ground truth to get the loss. I do backpropagation with loss.backward, and then update my gradients with optimizer.step. So I had to write a lot of things just to train my model. Then I also have to track my loss, track my accuracy, log it, which requires a lot more lines. If we keep adding all these things, this file will become from 25 lines to God knows 100 lines. But with Lightning Flash, what I can do is, since I know my task is image classification, I will just import from flash.image, image classifier and image classification data. My folder structure is, it is organized in a folder. So I will do from folders, provide the training data path and validation data path. I have created my data module here. Then I will use my image classifier model, and I will create a trainer, specify maximum epochs and a number of GPUs. Then I just provide my model and train it. It is not even 10 lines of code. And suppose if I want to use a logger or callbacks, I can just pass it as an argument inside the Flash trainer. It is very simple. Now, suppose if you do not have any machine learning or Python experience as well, you can use Flash Zero. Flash Zero provides a CLI for image classification, you can do flash image classification, specify max epoch in an argument like this, then use the backbone like model.backbone, and you can provide ResNet 18, ResNet 50, or any available backbone in Flash. And from folder, since my dataset is structured in a folder, I provide the train folder path. And if I run this, it will start training my model. I didn't have to write any code for this as well. So now training a semantic segmentation, and how did I started contributing to this library, and how did I make changes, and I will go through all the procedures, so that if you are starting and if you want to contribute, it won't be much difficult for you. So with semantic segmentation contribution, now you can load lot of multiple semantic segmentation backbones. You can just specify backbone efficient at V0 to resonate, and if any kind of pre-trained model available in the library here. So let me start directly with the code. So when you, first of all, you can go to Flash and just clone the repo. You can go to GitHub, go to Lightning Flash repository, clone it from here, and you can open it in your favorite editor, IDE. If you see Flash, it is organized in a kind of task-based folders. It has image, then tabular, point cloud, audio, graph, text, video. If you go to image, you have classification, detection, embedding, face detection, instance segmentation, key point detection, and segmentation. So I will go to segmentation. And here, before contributing, the main thing while you are contributing to Flash in image are backbones. So in backbone, there is a class called Flash registry. You can import it from flash.core.registry, import Flash registry. Then I have set instantiated this Flash registry, and this is my registry name, semantic segmentation backbone. Now, before this, let me show you the library that I have integrated. It is semantic segmentation models.pytorch, and let's see how cool this library is. So to instantiate any semantic segmentation model, all you have to do is import semantic segmentation .pytorch as SMP. Then you can do smp.unit, provide the encoder name like MobileNet or EfficientNet, ResNet 34, any kind of pre-trained model of your choice. And you can provide the weights. If you want pre-trained weight, then ImageNet, and number of input channels and output channels. Okay, so what are encoders here? To get the name of encoders like ResNet or EfficientNet or MobileNet, I do smp.encoders.get encoders name, and I have stored all my encoders in this variable. After that, I have to register all my encoders with this registry that I have created earlier. So for that, all I have to do is just call this library, Flash registry, and provide my function to load the backbone. I can also provide the namespace. Namespace is basically your task name slash the type of task. Basically, I am using image here, and then segmentation. I can also provide the weights path, so that if you want to load it from a pre-trained model, you can provide it in the configuration. So here I have iterated through all my encoders, which I got from the library which I am integrating, smp.encoders.get encoders name, and then I register all of the encoders inside the semantic segmentation backbones. Now, how am I using this backbone? If I come to model.py, so if you have already used Flash, you might have used this thing from flash.semantic segmentation, from flash.image import semantic segmentation. And in these are the arguments that you need to provide: number of classes, backbones, and head, then head quarks, then pre-trained and loss function, all of these things. If we check the class definition here, we have a backbones variable, which is semantic segmentation backbones that we have just created in the backbones module. Now, if we come here, the user will provide backbone ResNet 50, and this backbone, from this backbone, we will load the backbone. If we go downward, so here we have self.backbone is equal to our backbone registry dot get user provided backbone, which is ResNet 18 or ResNet 50. Then all the keyword arguments of backbone, if there is any, which is being passed into this. So if we remember in the last code, since I have already registered ResNet 15, ResNet 18 and ResNet 50 here. So when I do backbones.get ResNet 18, I will load that I will load that PyTorch model in this self.backbone. Now, similarly, when I do self.head is equal to head.get user provided head argument, I will be able to load the head as well. Basically, in a semantic segmentation model, we have an encoder and a decoder. Both the encoder and decoder are used together to train the segmentation model. Then you have all this training and validation step, which in most of the cases you won't need to use. So, and in case if you want to know what are the available pre-trained weights for me, you can do semantic segmentation dot available pre-trained weights. Let me show you in the notebook. From flash.image import just taking some time. I think my laptop has gone slow. I think we have 5 questions. Okay, so if I want to check what are the available heads, I can just call this function. And if I want to check what are the available backbones for me, there are a lot. If I check the length, more than 100 of backbones are available for me. DenseNet and EfficientNet, ResNet, MobileNet, VGG, exception. So to load the semantic segmentation model, what we need to do is we can provide head and backbone. Let me see if this is available for me. Okay, I have to import this first. Did I not download this. Okay, I think this data is not available on this system as well. Okay, here it is. So I have loaded my data module. Then inside my model, I will provide head, backbone, and number of classes, and my model is loaded here. So if I see my model, semantic segmentation, I have a head. So if I want to see my head separately, I can do model.head, which is FPM. So when I pass an image inside my model, it will first pass through the head, which is my encoder here. And you can see the output segmentation head. And it will have 128 channels. Then if I see backbone, it is an efficient decoder, which I have provided as backbone. So first my image will pass through the encoder, then the decoder. Now, if I want to train this model, all I have to do is create the trainer, provide the model, and just the data module. Let me set max epochs to 1 because I do not have GPU right now. Import Flash. So that's it. Just with 5 to 10 line, less than 10 line of code, you can instantiate everything you need to train your model and just fine tune any pre-trained weights available in Lightning Flash, and you are all set. So training has started. Okay. This will take a lot of time, so I will stop this. Okay. And if I want to do some prediction on my one of the image, I can just do model.predict and provide the path of the images, and it will do the prediction for me. Okay. What happened here? Okay. Oh, it's a lot of values. That's why it is not printing. Okay. So this is how you can train and fine tune any kind of model with Lightning Flash. Okay. And let's see what we can do with Flash 0. So suppose you do not know any Python coding as well. This is a CLI for you, Flash semantic segmentation. You can $help to get to know how you can use this CLI. Yeah. While it is taking time, let me quickly show you. So all the notebooks and materials are available in my GitHub repository, Aniket Maurya /talks. You can go to the state here, 20 1210 flashgrid.ai, and here you have flash.ipynb. I am showing you this notebook because I have run all the functions previously. So basically, let me go through all the codes quickly again. So basically, I loaded the dataset in pure PyTorch and then created the data loader. And I have visualized my images here. I have created a grid of image. Then this is a truck, deer, dog, and a plane. Then I have defined a model. I trained the model. And after that, I showed how you can do the same thing in Flash with just 5 lines of code. And with Flash 0, just 1 line of, not even code, just a CLI command. Then I showed you how you can train a semantic segmentation model with around 5 lines of code. And then Flash 0, yeah, it has loaded. So this is the uses how you can use semantic segmentation with Flash 0. Similar to this above command here, this thing, image classification, you can provide trainer dot, all the configuration of trainer you can provide like this, _ trainer dot maxibox, then model dot backbone name, and from folder. So if you come here, you can see the same things. So trainer dot serve sanity check if you want to do it. Then if you want to seed everything so that you can do reproducible training, and if you want to apply any callbacks, you can provide it here. All the configurations of trainer are available here. You can set devices, auto select GPU, and much more. Then for model, you can select the pre-trained model and model backbone and model head from this CLI. So basically with Flash 0, even if you do not have any experience in Python as well, you can just build your semantic segmentation model. So yeah, that's all from my side. If you have any questions, feel free to ask in the chat.
So Aniket, it looks like in the chat earlier, we had a couple of questions about if the notebook is publicly available right now.
Yeah, the notebook is publicly available right now, and it is available in my GitHub repo, Aniket Maurya /talks. So you can go to this today's date, 2021-12-10, and you can find the notebook here.
Is there a way that we could maybe send the link in the chat to the panelists?
Yeah, sure.
Okay. And it also looks like Hyunjin was asking about seeing the result from prediction at 0.
Okay. This one. Okay, this semantic segmentation prediction 0. It is basically, so here, let me give only one file path. And this is output image, because when in semantic segmentation, you provide an image and you get an segmented image. So this output is an image, and basically pixels of the whole image. So
he is asking, would you turn it into a mask image?
Yes, it is a mask image. So in a semantic segmentation model, when we provide an image, we get an output image with the same dimension. And suppose if you want to train a model to identify human face in a background containing human face, so it would maybe, if you have only a single class in case of human face, so it will give the same image with value 1 around your image, around your face in the image, and other values will be 0. in this case, I had number of classes 21. So you can see values are more than 10.
Alberto is saying maybe you can convert the output of the prediction to IL.image.
Yeah, I can convert the output of the image in a PIL image, but it won't look better because this is not coming from a train model, because I just stop it in between. Otherwise, it will take a lot of time to train me. So the output would be very weird or not good. So let me try this right now. Oh, it is. I don't. It brought it from Matplotlib. I can see the contrast here, but I think it might not be visible in this from the video call.
He's saying multiply it with 10.
Okay. Thank you for the suggestion. Yeah. So let me also open the original image. Yes, so this was my original scenery, and this is the output mask. I don't know if it makes any sense because this is not a trained model. Okay. So if you want, you can open this notebook in Google Colab and try it yourself. And this data that I have used, you can download it from this function here. Download data, you can provide this link, it will be downloaded to your folder. So after downloading it, you can just run all this code in your notebook or in your local laptop.
Great. Are there any other questions from anybody? Trying to see if we had any left in the Q&A. And then I don't see anything further in the chat, but yeah, thank you so much, Aniket, for this awesome presentation and being the first for our contributor meetup. So if anybody has any further questions, we're going to get this recording out to you directly through email. This recording will also be on our Lightning YouTube channel as well, and we'll likely share it on social in this next week. So if you didn't attend the full meetup, you'll be able to catch it either way. Thanks again, everybody, for your participation, and we will hopefully do another one here soon.
Thank you, Taylor. Thank you, everyone, for joining.
All right, bye now.
Bye, thanks.